Providing water for the London area is quite an engineering challenge. 6 million people get through an awful lot of it. In fact, an average of 2,000 million litres every day. And London isn't as rainy as people think. It gets half as much rain as Sydney and less than sun-soaked cities like Rome and Dallas. Despite cutting leakage, installing water meters and educating customers to use water wisely, freshwater supplies are already at their limit. And this is set to continue as climate change threatens hotter, drier summers and a relentless population growth puts further pressure on existing water sources. London running dry is just not an option. Thames Water had to find a new supply that could, when needed, provide the capital with extra water quickly, efficiently and sustainably. So what's the solution? It's a new treatment works at Beckton, East London, which uses desalination to turn brackish water from the tidal Thames into drinking water. Run on electricity generated from biofuels like used cooking oil, the new £270 million works and pipeline have been designed to be as sustainable and efficient as possible. In fact, it's the world's first four-stage reverse osmosis system, turning 85% of water taken from the tidal Thames into drinking water, compared to about 50% at other desalination plants around the world. But how did they do it? The location was key in making the design as efficient as possible.
We sited the desalination plant at this point because this is land that Thames Water owns and it's as close as we can get to the source of the river in terms of the water coming down towards the sea. So this was a good spot for us. We had a pilot plant which we set up in this area so we could test the water that we would actually abstract. And during that pilot plant testing, we developed the designs for the water treatment works.
7 submerged pumps extract water from the Thames during the last 3 hours of the outgoing tide, when the water is least salty. The water is then piped into storage tanks via 2 1400mm glass pipes, which are reinforced with epoxy.
The water that we take is far enough upstream to ensure that we capture as much fresh water that's coming down the river and less salt content. We found that the salinity of the water varied considerably between the high tide and the low tide. We then looked at, well, if we took the water out a lot quicker and if we could store it somewhere, that means that we would be able to treat lower salinity water, which would mean the plant would be smaller, more sustainable and use less energy.
Thames Water refurbished 4 existing storage tank facilities on the site, which can hold 180 million litres of water. Angled inlets create a figure-of-8 flow pattern to ensure water coming into the tanks is rapidly mixed. This keeps salt content evenly balanced, which improves efficiency of the filtering system and the reverse osmosis process. The water is then pumped into lamella clarifiers by 4 variable speed submersed pumps. A coagulant is added to make suspended material stick together and settle out, a process used at many of Thames Water's existing treatment works. The water's then filtered through a 1-metre bed of sand-based material housed in stainless steel tanks to prevent salt corrosion. The water then enters the main section of the works where it goes through a final clean before the reverse osmosis process starts. The salt is then removed by forcing the water under high pressure through 7 very fine spiral-bound membranes with pore sizes less than 1 nanometre wide. The water collects in a central tube and leaves the salt behind. There are 10,000 membranes stored in vessels, and if laid out flat, they'd have the same surface area as 54 football pitches.
This is a crucial part of the process. This is where the clean, salty water comes in to go through the reverse osmosis process. This is the world's first 4-stage reverse osmosis, and it means that the water that comes in, 85% of that is turned into drinking water.
To make the process efficient, each reverse osmosis stage has its own feed pump, which can be adjusted to suit the salinity of the water. This means that the process never uses more power than necessary. The wastewater saline solution is then combined with effluent from the sewage works and discharged into the estuary. Power consumption is also monitored in real time, allowing Thames Water to meet site demands efficiently and cost effectively.
At the end of the 4th stage, we take the energy off the end, pass it through Pelton turbines, and that recovers energy. So the only energy that's used in here is what's required for the process alone.
Minerals are then added to the desalinated water to make it taste as much like traditional tap water as possible. It's then pumped into existing supplies via a new 14-kilometre pipe. In tests, some customers preferred desalinated water, and most couldn't tell the difference. Gateway can produce up to 150 million litres a day. That's enough for 1 million people. And thanks to that forward-looking approach, when the next drought arrives, this state-of-the-art facility means London will always be prepared.